The DL streamer can help you construct AI analytic pipelines very fast, very efficiently, using ready elements. The end application is a GStreamer pipeline, and the building blocks are GStreamer elements plus a selected list of video analytic elements with the prefix GVA. You can basically use any GStreamer element and any of the elements provided by the DL streamer to build your pipeline. And it is all working great, as you've seen in previous videos. But what if I need a custom element, one that is not included in the list? For this, we can create a custom new element written in Python using gvaPython. But first, we need a little deeper understanding on the way the GStreamer pipeline is being transferring data around. The GST-Buffer holds the frame's information. Every pipe stage can read the GST-Buffer information as an input and may write information to the buffer as its output. For example, if we are performing detection, the GVA detect element will add metadata information, which is the output of the inference, to each frame inside the GST-Buffer. So each frame will also have a list of bounding boxes and the confidence level and the object classes or whatever for each detected object. The GST-Buffer is a structure used by the DL streamer to hold the video frame and also the inference, metadata, region of interest, tensor outputs, and more. Since GStreamer is usually dealing with mostly video at the frame level, the DL streamer added few metadata structures to the GST-Buffer for holding the inference results and more. Navigate to the DL streamer webpage, go to the developer guide and to metadata. I'll leave you the link below. If you scroll down, you can see a very interesting table describing operations by the DL streamer and how does the input and the output look like. For example, object detection using GVA detect is taking the input from the GST-Buffer and the output is a GST video region of interest meta structures. If you look it up in the GStreamer documentation, you can see how it is defined. Here, for example, is the definition of the bounding boxes and more. Detection with standard outputs does not need any special operation, so we can use a standard GStreamer data type. But if you're performing just any inference with GVA inference, the input will come from the GST-Buffer and the output will have to go into GVA tensor meta. And here you can see the definition of the GVA tensor meta and also the GVA JSON meta. You can see here the code and exactly how the structure is defined. Under the same directory, you can also see other structures unique to GVA. For example, for video analytic, for video frames, tensor, and for example, the region of interest. And you can see clearly how the data is structured, how the regions of interest are defined. Here is the label, here is the confidence level, the object ID, and so on. This document, I'll leave you the link below, basically summarizes the metadata structure. You can have a GVA video frame that holds many regions of interest inside, each for a different object, and each region of interest might have a different tensor object to describe the properties for that object. I'll show you an example how to build a custom operation, but you can find here the code to access the custom metadata and how to manipulate or use the data of each of these inference outputs objects, here in C and here using C++. Okay, let's run an example. DL streamer documentation, Google it, link below, get started, and for this example, I'll run using Docker. First, set the models directory. For me, it's the home directory /models. This is the explanation on how to get the models from the Open Model Zoo. We already got the models downloaded, so we can go ahead and just get a ready DL streamer environment using one line of code. Choose the right version, I'm going to add few things to this line. First of all, I'd like to run it as a root user, and I'd like to be able to display the output to screen from the container. So set the display right. It brings over the DStreamer image and run it. And I have a ready environment. First thing, let's run the sample as is. It's under the DStreamer samples, under gvaPython, and it is a face detection and age and gender classification. Faces are detected, left is female, on the right it's the male. Let's back up a little. This is the actual code that we're running. GST launch and so on. Let me try to arrange it. First line, we take the input video file and decode it. Second line, GVA inference, perform face detection. Then we run a Python script using gvaPython, another inference, and then 2 more Python files. And finally, watermark, convert back the video and show to the screen. We have seen the full sample code. Now I'll try to run it line by line and show you how it all works. This is the full sample. I'm going to remove everything but the face detection. Basically, leave only the inference and the gvaPython. Running and faces are detected. If I remove the Python script and only execute the inference, nothing really happens, no faces. If I replace the GVA inference with GVA detect, what do you think will happen? It is all working well, but why? This is the same model. We just changed the command. I think it's a good time to look into the GST-Buffer. Let's print the GST-Buffer results. You already know how to do it. I'll use meta convert and then meta publish into a file. Let's run and look at the output file. You can see how the results are well organized. Each frame has 2 detected objects, 2 faces, female and a male. Because we have used GVA detect, DStreamer knows that this is a detection model and what the results mean. If we print again the GST-Buffer, but now for GVA inference instead of GVA detect, you can see the results look totally different and the DStreamer doesn't know how to arrange them. This is exactly why we need a Python script to explain the DStreamer what to do with the results, to help it with sometimes pre-processing and sometimes, like in this case, with the inference post-processing. Let's look at the Python script, SSD object detection. The best and sometimes only way to understand the output of a model is to check the description. This is the OpenVINO model zoo, and this is our model, face detection for ADAS. And you can find here exactly how to interpret the output of the model, the image ID, the label, the confidence level, and so on. And this is why the Python 3 script look like that. DStreamer is looking for the main class. Here, there's only one function, so it uses process frame. This function will return a true value if everything goes well, and if not, that specific frame will be dropped. The function looks at the frame tensors. For each tensor, it grabs the dimension, the data, and the object size, and it calculates the image ID, the label, confidence level, and the bounding box, all placed nicely into the ROI and added to the frame, basically to the GST-Buffer. Once all the metadata is organized inside the GST-Buffer, the rest of the pipeline can read and understand it. For example, GVA watermark can clearly present the bounding boxes over the faces. So far, we have performed face detection. Since we did it using GVA inference and not GVA detect, we need to organize the results using a Python script. The rest of the pipeline, the next element, will run classification, but not on the full frame, only on the faces. And again, we need to explain to them where are the faces. We need to run the classification model, and then we will use another Python script to calculate the results. We've ran the first inference face detection, we ran the Python script to arrange the results. Here, we run the next inference, but it is done only on the faces as defined by the ROI list. And we run an age and gender recognition model, followed by this Python script. Let's look at the model. The OpenVINO model zoo, age and gender recognition model, and here is the definition for the inputs and the outputs of the model. This is a model itself. The input is a 62 by 62 pixels face, and the output, there are actually two outputs. The first is just one number, and the name of the layer is FC3. You can read in the documentation that it represents the age of the person divided by 100. The layer we're looking for is the one before, and it is called ageconv3. So the Python script is asking, is this layer ageconv3? If yes, we add a label by the name of age with a value multiplied by 100. The next output is a 2x1 vector that determines the gender. The layer name is prob, don't ask me why, so the Python script finds a layer called prob. It will set the gender according to that value, and it is running nicely, detecting the faces and the gender. The capability of building your own custom element using gvaPython adds great flexibility to the deal streamer and allows you to use your own crazy model or your customized operation to the rest of the deal streamer elements. But how fast can it run? Next video, let's talk about performance.